I'm not sure what would actually happen, but I mean, I don't think it's good. If you're supposed to start with 10 and you start with 300, and they think they think the normal max is 100, like that's as high as you're gonna go.
Yeah.
Well, you got, you know, more body mass.
Yeah, except it doesn't work like that because it's therapeutic,
Really?
so it like just builds up in the system.
No.
Yeah, because there's a like in my blood tests they take a lamictal level. I think it's a I don't know if it's a hormone or a chemical. Maybe that's the same thing inside the body. I don't know, whatever. But I mean, it like shows up on a normal blood test, like it's a something they measure inside of people. I don't think they can like bring up like Tylenol levels. Although maybe they can. Isn't Tylenol acetaminophen? I bet you they probably can get acetaminophen levels. So I don't know. It might be made up. I don't know. Mr. Gonzalez is a uncertified MD. Well, you saw his post about low cost surgeries. Remember that one? So after I had my knee surgery, he had a picture of him with my like post knee surgery knee still in the cast thing and with his machete offering to do budget surgeries. At some point, I really have to start a GoFundMe page for Mr. Gonzalez and see what he actually could raise. Just out of just the insanity. Just see if he could actually... Like, I could see it, like, the joke turning into, like, him raising, like, $300,000 or something like that, just out of this, like... He just had this, like, horrible backstory. He's like, I have identical twin cousins all over the world. Help the research for this genetic disorder. All right. Which leads us into object-oriented language. So, okay. So for homework for today, we were supposed to create our initial constructors for program, class, and method. Those three. Okay. So now we're seeing some similarities between our previously created language, right? And then this guy. But would you say you also see similarities between like a procedural language like C and an object-oriented language like Java? Yeah, but there's a lot of overlap. What do we really see as the differentiating factor between? I know, so a lot of you are working. Several of you are in the 350 class this semester, so you're working with the with C in there, right? Mm-hmm. What would you say is the main differentiating factor, or the main struggle you're running into coming from a Java or C# programmer and going into C? What are you losing? Go ahead.
Well, like you have structs, but they're not really the same as classes because you can't have methods in it.
Okay. And how is that impacting you as a programmer?
You have to like write all these methods that take in variables that they act on versus like just like I don't know, calling a method on an object.
Okay. So the idea is you've lost an organizational structure, right?
Yeah.
So you can no longer conceive of your ideas in terms of objects, where you can have all the details associated with a specific object inside of that bucket. Mm-hmm. And you can't have the fields, the methods, and the constructors housed inside of an individual bucket that you can now pass around as a whole thing. Instead, what you can do is you can create kind of specialized halvesies variables, right? Where you could say, well, under a single variable type, I'm going to remember 3 or 4 pieces of information. And then I can write a whole bunch of completely separate functions that can operate on those kind of pods of information. So what structs effectively are is classes with only fields, something along those lines, right? So, but at the end of the day, you really have lost an organizational structure. So when you came into the mindset of C, well, when you came into the C language with the mindset of a Java programmer, you wanted to think about all your problems and the solutions to your problems in terms of objects, because that's how you're used to organizing your solutions to your problems. Where now you've lost that ability. Well, in our case, we've now gained that ability. So if you think about when we wrote our, as we try to write more and more complex programs in our made-up language, it started becoming a little bit difficult to write the syntax because we were having to be very verbose and remember different things, but we weren't able to organize stuff into little pods that operate on it. So our language, we could see, was going to become pretty unwieldy pretty quickly, right? In the early days when we only had one or two things, especially after we got the begin statement, or what I would call ours, block statement. Once we had that kind of opened it up to us to do some more powerful things, but we still saw like one of the challenges for several of the homework assignments was coming up with a test case, right? Because and a lot of times in class, what was our biggest mistake? We'd have correctly written code, but a incorrect syntax in our language that wasn't going to be compatible with our interpreter. All right, so this gives us a level of abstraction, a higher order abstraction than a procedural language gives us. All right, so a program is going to have 0 or more class definitions, and it's going to produce a list containing a program followed by a list of class declarations, followed by a body for the program in which that happens. All right, so I'm going to we're going to create a new, go ahead and save this as CSC470, Can we read that? Is that big enough? All right, so we're going to define program constructor to be a lambda that's going to take in a list of classes and a body. That's what that guy's going to need in order to work. We go back here. He needs a list of classes and then a body. All right, and we'll go ahead and create a list out of a program, then our list of classes and our body, something like that. That would be a reasonable thing to write. And then we'll write our predicate for this. And what might be, what do we call our grammar here? What did the book call our grammar? They didn't give us, so we're going to call this, we'll just call it an expression like that. And we'll return EQ, a program, car VXP, something like that. And then we might have the getters, and so we'll have a define get program classes, and that'll be a lambda that takes in a program, and it's going to return the catter of that program. And then define get program body. It's going to be a lambda that takes in a program, and it'll return the body of the program. All right, so that seemed reasonable for program. All right, and then we have a class. So a class is going to take in the name of the class. It's going to take in who he extends. It's going to take in a list of 0 or more fields, and then it's going to take in a list of 0 or more methods. Right? Now notice that a class does not have a body. Let's connect this to our understanding of Java. When we create a class like the fraction class or something like that, that is an organizational structure that stores some information about fractions, that knows how to operate on fractions, but it doesn't actually execute in and of itself. The only classes that actually have a body in Java would be the class that has main in it. right? Because that's where it starts. So that's kind of our hack class that allows you to start a program. They've just hidden that body inside of a class where main lives. Make sense? Did they have to do that? Could they have designed Java differently? I mean, that's an a design decision for Java. Couldn't they have created a new type of thing called a program? And the program is the thing that actually had the body? And that body was being run in the context of this environment that contained all of your class definitions? I mean, we sort of have that in Java, don't we? Isn't Java, you get a default package if you don't actually define one. But Java effectively has this thing called a package, which is a collection of classes, right? Gives you some organizational structure where it's basically it uses a normal directory structure and refers to that by dots. So it's kind of the programmy version of talking about a directory structure. But ultimately, a package is a collection of classes where somewhere in there you're going to have a class with a main, and that's the guy that would actually execute your program. Is it actually maybe a bad idea for them to arbitrarily hide the body of the program inside of a class? Is that a little bit confusing maybe? Like if you're thinking about learning object-oriented programming for the first time, and I'm teaching you that, just like we're talking about here, that classes are collections of fields and methods and constructors. Last time we talked about that sometimes methods and constructors can be one and the same, depending if the language itself differentiates between the two or not. But it's always a collection of those two or three things, let's say. Is it confusing then to all of a sudden throw this curveball and say, oh, but by the way, put main inside of one of your classes, and by the way, it has to be public static void main. That way the Java virtual machine knows how to call it. Because we're basically saying you have to write your code in this very specific way so that the JVM, the Java virtual machine, knows how to, he's gonna look through your classes. He's gonna find the guy that has main. And he's gonna start your program there. Is it a little bit confusing? Aren't we kind of hijacking the idea of a class? Kind of see what I'm saying? So we're making a design decision here that we might say is actually superior to Java's design decision. At least in my view. Can anybody make a strong argument why Java's design decision, where they hide the body of the program just magically inside of a class, why that makes sense? Why do you think they chose to do that? Go ahead.
In a way, it makes sense when you think of the object model as being kind of how we think of problems. And so you have these physical objects that can do things, and then you have the orchestrator, who represents the main function, who is then manipulating these objects. So why wouldn't it be an object in?
So maybe taking like a car analogy,
right,
where a car is an object, and what makes up the car object is a whole bunch of other objects, right? All the way down to a little nut and bolt and that kind of stuff. But ultimately, you get in the car and you turn the key, or you start, and that gets the engine running. That's how a car begins, right? So you could make the argument that any solution is in the context of an object, right? So, that we might say that completely mimics the way human beings solve the world's problem. Like, right now we are in a room. This room is in a building. This building is in a town. This town is in a state or is in a county. This county is in a blah, 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 right? And then at some point, I think there's probably a Christian worldview thing there where we get up to some sort of level where there has to be a creator, right? There's got to be a beginning point. So,
Turtles all the way down.
Yeah. Okay. So but the idea here is that is how human beings conceive of the world around them, right? Now, programmers, though, might conceive of the world around them, their solutions as, oh, this is my program, and my program is made up of a collection of objects. Okay, so we we keep our Legos in this bucket, and that bucket has nothing to do with Legos other than that's where they live. Yeah.
So this leads me to a question I came up with while I was putting the structs together.
Yep.
The constructors. Why does our program not have a name, but the class has a name and the methods have names?
That's a good point. I think, because our language here, do you want to take a stab at it first, or do you want me to give you a...
No, I'm just curious. Why can we not have multiple programs running?
That's the exact point. The interpreter, as it's defined here, says our interpreter runs a program.
Okay.
It runs a single, in fact, they even call it a program, right? Now, you might say an operating system is a collection of many running programs. Right. Therefore, we'd like to give names to those programs. We have Microsoft Word. We have Gmail, whatever, blah, blah, blah. Yeah.
So, in essence, program is just a bucket to contain all the classes, but it has no other purpose.
Correct. Yeah, I mean, a program is, hey, here's all your classes, your objects in which you're solving your problem, and then here's the body of it. Instead of saying that the body lives inside of one of those classes. So from a programmer-centric perspective, I might look at this and say, okay, at some level, if you're telling a computer what to do, at some level we are writing a program, right? And even though a human being solves problems in their world in terms of the objects around them, at the center of that you have, your consciousness working with your brain, right? And that's kind of our program. And that is different than the objects you're manipulating to solve a problem. So from a computer programmer perspective, we may want to differentiate between, our Legos that we're solving our problem with, our objects, our classes, and the problem that we're trying to solve, the solution that we're trying to solve. Go ahead.
So a namespace is a collection of classes, but that's like it's not a program. Is that like somewhere in between there? We're just not worried about that? Because a namespace would be a collection of classes, and then you could have another namespace as a collection of classes, but they were in the same program.
Well, right, yeah. So, namespace is to C# is like package is to Java.
Package to Java.
Yeah,
But
so,
that's not a program, correct? It's like an in-between step.
Well, it is your, it's a way of organizing the players in your, that go into your program. So, for instance, if you're solving some problem at the house, you're working on some project, and you might say, okay, well, I need some objects to solve this project. You wouldn't get all of your objects from Home Depot, right? So some of the objects you have in mind are part of the Home Depot namespace or the Home Depot package. And you would go to Home Depot and you would pick up those guys because that's it makes sense. Those are things that Home Depot sells, right? Then other ones would be in the Meijer package, the Meijer namespace. You go to Meijer to pick up those. So on and so forth. So that gives us, these are all those organizational models for the program / human, and I sometimes use those independently, because not all programmers are humans, right? Exactly. I use that pretty often. I said, you humans, you just confuse me. So it does become an interesting chicken or the egg type of, let's call it somewhat joke. But I almost like this idea here. Instead of calling this a program, I want to call this a solution. Okay, this is the solution to a problem. All right, and we're going to call this guy a solution. You can name yours whatever you want, but I kind of like this idea of really calling these what they represent, moving it away from our normal vernacular. So we'll call this guy Git. Actually, this guy's just solution.
And that might have been part of what confused me, because it's like a program, and then So can there be more than one? Okay, yes. We're only running
Yeah, because who in your computing world runs more than one program?
operating
An operating system. Yep. So the operating system has the interpreter, and every single time you want to run a program, it launches a version of that interpreter to run that program, and that program has its own variable environment and all these things.
But if we were doing like a combo IDE interpreter, then we'd maybe want names on our programs.
Well, maybe. I mean, if we think about the way an operating system world might use, where do we store our programs? We store them in a file,
Right.
right? So if you think of your interpreter as kind of like a DVD player, you insert a file, hit play, and it runs that that program. All right, so I'm just changing vocabulary here a little bit to kind of support this rethinking of what these are, because a program really is a solution to a problem. And as you pointed out, we solve problems in terms of objects, right? So that's why I kind of like the idea personally of separating the idea of a class and a solution. We are solving a problem. And when we solve a problem, what's that called? It's called a solution, right? We have a solution to the problem. Now, the things we're using to solve the problem are a bunch of objects, right? That's how we create solutions in terms of our objects. But we still, as a whole, talk about our means to solving the problem as a solution, not as a class that has your starting point of your solution inside of there. You probably can make the argument either way, but I think at some point it's not unfair to say that a programmer could differentiate their humanity from, I'm telling a computer what to do here. So at some point it's, I'm creating a solution to a problem. Design decisions. Yeah.
So remember 5 minutes ago when we were talking about why Java is the way it is?
Mm-hmm.
I think I just figured it out, like the actual reason.
Okay.
It's because aesthetically, having to define all our classes, in very verbose detail, and then finally we get to main, I don't think aesthetically that looks very good. So Java said, okay, well, we want to prioritize having a multi-file model, and just as part of that, it makes the most sense to have main in an object. Otherwise, you're going to have one file that's weird and different from all the rest.
Now, here's an interesting thing. I mean, you're not wrong. We've obviously talked about this probably enough from the perspective of you can go either way with this, right? Now, one interesting thing is C# came out post Java. That was the whole lawsuit thing. Microsoft lost, couldn't use Java in their name, blah, blah, blah. So they came out with C#. And that's kind of when Visual Studio was reinvented, let's say. Now, what's interesting is when you have a project in Visual Studio, what's it called?
.solution.
It's a solution file. So somewhere in here, we're kind of talking about what's actually happening. We can name our stuff whatever we want, and we could probably make pretty good arguments across the board for it. But now, even saying that, even though your project is called as a .solution file, it still is going to run your main program that lives inside of a class in C#, as opposed to there just being this like new type of statement, new type of expression called a solution expression or something like that, that houses your solution and maybe has a place where it just is called start. In this case, it's called body, right? This is the body of my solution, but let's say whatever. All right, so we rename this guy to solution. We can still call classes what they are. A class will have a name, who it extends, and then a list of fields and a list of methods. So we're gonna define class to be a lambda, and this guy will take in a name a parent name, a list of fields, and a list of methods. And we will boil down to a list containing a class, name, parent name, list of fields, list of methods. All right, so that's what wraps that. We'll define the class predicate to be a lambda. It's going to take an expression as a parameter, and it's going to return whether the car of that guy is equal to a class. Then we're going to define do we like it get solution classes or solution get classes? Probably doesn't matter. Let's just keep going. So we'll call this guy get class, get name.
Which would you want to do?
No, get class name. Get class name.
Yeah, we can do.
We can't do both. You're not going to let me do it.
I mean, go for it.
So here we'll call it get class name. This guy will be a lambda that takes a class, and as a parameter, it returns the car of that class.
How many gets did I use here again?
Define get class.
Wouldn't it be the getter of the class?
Yes, thank you. I'm gonna just steal the body here. Get class parent name, and this is the CADDR. This is get class fields. DDDR. Get class methods. DDDR.
Does 4Ds actually work?
I would assume so. You don't think it will?
I know it limits you. I think it might.
I think four does work. Let's see. So we need a.
We're getting close though. We're getting close to it.
I don't know, there was some addition problems we were doing, but I couldn't jam it.
Oh.
Yeah, that.
Yeah.
Killing me.
That's what I used.
Too many A's.
Yeah, that's too many A's.
Who?
So it should be the
It should
candidate
just be
of
the
cutter.
candidate of the could.
Oh, thank you.
E.
Yeah, so I guess 3. No applause, please. Oh, too late. I'll take them.
Take my hand.
No autographs. Okay, so that is that piece. And then we have method. So a method has a name, it has a list of parameters, and then it has a body, right? So define method to be a lambda that takes in a name, it takes in a list of parameters, and it takes in a body. And this guy will create a list. Method, name, so a So that's the constructor or the predicate for method. And then we need to get, we probably could argue whether or not we need a get name, but we'll go ahead and do it. Steal this guy. So get method name. This guy will take in a method as a parameter and return the getter of that method. And then we'll have a get method params. And then a get method body. Now what's interesting here, and when you, and this is rolling back, I don't know, 4 minutes or something like that, when Eric asked us, and he said, does 4Ds work? He actually already knew the answer. So it was kind of a trap. True?
No, I didn't actually. I just wrote it. I remember on the test there was a limit to how many D's you could use.
Oh, I see.
I didn't remember, so I just wrote it as the cat.
The car of the cooter of the cooter of the cooter.
No, I didn't. But thought
I always limit myself to 3Ds.
I knew the limit was either 4 or 5, and I just didn't remember.
It was neither of those. Oh, yeah, that was where the stopping point was, 4 or 5. It's still a trap. You've lost a point for the day.
Might I suggest we change from these taking in a method to these taking in meth?
You want him to take meth in?
Yes, I want them to take meth.
Yeah. 9. All right. It's getting pretty bad. Okay. So what would happen next? So now we have this idea of what's an expression. So notice here, now when I say the new keyword in Java, what's the new keyword? Go ahead.
Memory allocation for an object.
Okay, so that's very programming-y. I usually refer to as our real estate agent, right? Goes out and gets a memory address for the plot of land where we're going to build our thing. So this is memory allocation for an object. So if the people that are going to be using this are programmers, then we would actually have a solution to our problem, not something hidden inside of a class, right? So that's why our choices here make sense. All right, so we have 4 kinds of expressions that they've started us with here. So one of them is a new expression. And a new expression is going to take in a identifier as well as a comma-separated list of expressions. What is this guy? What are we trying to emulate with that? What's the identifier?
Last name?
Probably a class name. If we think about this in terms of Java, we might say, I'll just refer back to the fraction object I mentioned earlier. We might say fraction f is equal to new fraction, right? We're creating an instance of our fraction, right? Okay, so identifier would have to match the name of one of our classes. All right, and then what is inside the list of expressions there? Okay, for the constructor, right? Okay, so I think last time we decided, do we have, we were talking about the idea of constructors versus methods, and I said that some languages have a built-in constructor that you would call, or they have the constructor match the name of the class. So that means inside of our class, we would actually have a method that either had a very defined name, like init, something like that, or match the name of the class like Java and C# do. So by my example, we would have a method-looking thing called fraction. And that would be the guy that would automatically get called when I was creating a new instance of this by passing it those expressions. So these expressions are the values. Those expressions will boil down to values, right? They'll be passed in at some level into our interpreter. They'll boil down to some values. Those values are the individual parameters being sent into the constructor for this instance of our interpreter, or this instance of our object, rather. That makes sense? That's what we're doing here. So, we're going to call this guy, or what I'll end up calling this guy next time is we're going to call this guy a instance expression, or maybe instance exp, something like that. All right. Similarly, let's look at this next guy. This next guy is a send expression. Now, we mentioned last time that in Java, our expressions are represented in dot notation, right? But effectively what we're doing is we are sending a message to an instance of a class. Make sense? So here's the, here's the beginning of it. We are sending something. What are we sending? The result of this expression. Who are we sending it to? We're sending it to this identifier. Now, what's this stuff over here? What's being accomplished in that send expression? Go ahead.
That's like parameters that are getting passed into that method.
Okay. So we are sending this expression here. What does this expression boil down to then?
Method name.
Method name. So we're sending the message. What message? The method name. Who are we sending to? This class. This is probably a variable name, right? That's going to boil down to an instance of a class. And what are we passing? What message are we sending it? Well, we're saying, look, you're this fraction, this instance of fraction. I want to send you I'm going to call the add method, and you've told me you need two pieces of information for that to work. A fraction 1 and a fraction 2. So I'll pass you the expression for my first fraction and pass you an expression for my next fraction. Those are the parameters I'm sending to the instance of my class that's represented by identifier, this identifier. So this is the method name of this instance, whatever this identifier boils down to in our environment, and I'm sending him these parameters that he should pass to that method. All right. So we're going to call this a method call expression. Now, what's this guy? What's a super expression?
Parent or inherited class.
Okay, so whoever's the one level up from me, right? And what are we passing here?
Another method name.
Okay, so this is just like our send expression, our method call expression, except we are asking our parent to call one of their methods, right? So method call expression, and we'll call parent method call exp. We're not even going to check within ourselves, because we could have a situation where we have a method and our parent has the identical method, and our method will come up first. So instead of this, we're allowing us to say, I want to specifically call my parent's version of that method. Make sense? Good.
Out of curiosity, are we putting like the location of that super method or class or whatever inside of that method class, or are you having that outside?
Oh, we're talking about the implementation?
Yeah.
But it'll be inside. Well, more than likely it'll be inside. A object will know about the instance of his parent because he was built in terms of that instance. When we create an instance, we're going to build an instance of the parent. All right, so that's this last one. And then what's a self-expression? A self-expression is how we refer to ourselves within ourselves. All right, so this is going to be a self-EXP. So for next class, we want to write the constructors and any getters and things like that we'll need for those 4 pieces. And then next class, we'll be able to start working on the actual interpreter. Make sense? So I'll give you this code as a starting point.
Go.
And I'll put the homework up on Blackboard. Questions, comments, concerns, bribes. Also notice my note I put in Slack. We've been having some poor front row club attendance at chapel. That needs to improve. Jack, Blaine, Austin, V.
Why am I not? I'm not even signed up for it.
No, everybody in this room is signed up for that club.
Did you put anything in Slack?
Yeah, it's in
Where's
general.
Rob Brew?
Eric's always at chapel. Well, he sits with a girlfriend, so you know.
Oh,
Are you trying to news me? What's
Why are you playing footsie with my